Hello students, so welcome back. We are doing exercise 21E from trigonometry, isn't it? So in our previous videos we have completed till question number 12, and today we'll start from question number 13, and in this video we will conclude this chapter, okay? And from the next video onward we will move on to the next topic, that is height and distance. So let's begin. This is question number 13. If 0 degree less than A less than 90 degree, which means angle A lies between 0 degree and 90 degree, okay? Angle A is greater than 0 degree. Let me explain this here. This is not the condition here, okay? This means angle A can be 0 degree or greater than 0 degree. Angle A is greater than or equal to 0 degree and less than or equal to 90 degree, which means angle A can be 90 degree or less than 90 degree, but cannot be greater than 90 degree and cannot be lesser than 0 degree. But this case is different. If this is the condition, this means angle A cannot be 0 degree, angle A should be greater than 0 degree, and here angle A should be less than 90 degree. Angle A should not be equal to 90 degree, okay? Here we have equal to sign, the symbol equal to is here. Here we don't have equal to. Angle A is either greater than 0 degree or less than 90 degree, not equal to, okay? So we must keep this in mind. So this is the given condition to us. Angle A should lie in between 0 degree and 90 degree. Angle A cannot be 0 degree, must be greater than 0 degree, and cannot be 90 degree, must be lesser than 90 degree. So we are asked to find the value of angle A from this equation. This is question number 1 of 13. This is the given equation to us. From this equation we are asked to find the value of angle A. So let's begin. Let's take the LCM of the denominators, 1 minus sin A and 1 plus sin A. Okay, there is plus sign in between these two fractional numbers, numerator denominator. Numerator denominator means this is a fractional number and this is a fractional number, there is a plus sign. So we must take the LCM of the denominators, isn't it? So when we take the LCM of the denominators, what we usually do is we multiply these two numbers, because these two are totally different, isn't it? There is no common multiplication table in between them. So we multiply these two numbers, we get 1 minus sin A into 1 plus sin A. 1 minus sin A into 1 plus sin A. So this is A minus B into A plus B, isn't it? So A minus B into A plus B is actually A square minus B square. A minus B into A plus B is A square minus B square. So instead of writing 1 minus sin A into 1 plus sin A, I can write A square minus B square. Okay, A square minus B square. A minus B into A plus B means A square minus B square. So 1 square is 1, so no need to write this square as well. 1 square is always 1. 1 square is 1. 1 to the power 5 is 1. 1 to the power x is 1. 1 raised to power any number is always 1. Okay. So 1 squared is 1. So we don't write squared here. 1 minus sin square A. Now when we multiply 1 minus sin A with 1 plus sin A, we get this, isn't it? So 1 minus sin A into 1 plus sin A is this. This means 1 plus sin A into cos A. So we multiply cos A into 1 plus sin A, okay? So cos A into 1, cos A, plus cos A into sin A, cos A, sin A. Now this plus sign comes here. Cos A into 1, cos A, plus into minus, minus, cos A into sin A, cos A sin A equals to 4, isn't it? So this plus cos A sin A minus cos A sin A, same number but opposite sign. This is minus and this is plus. So plus cos A sin A minus cos A sin A can be cancelled. So we have cos A plus cos A. This cos A is also plus and this cos A is also plus. Cos A plus cos A is 2 cos A. Okay. And in the denominator we have 1 minus sin square A. 1 minus sin square A means cos square A equals to 4. Since we know that sin square A plus cos square A equals to 1. So cos square A equals to 1 is already in the right hand side. Let's take this plus sin square A to the right hand side. We have minus sin square A. This means 1 minus sin square A means cos square A. So instead of 1 minus sin square A, I can write cos square A. Now we have cos square A in the denominator and cos A in the numerator. So let's cancel this cos A and 1 cos A from here. Okay. Cos square A means cos A into cos A. Cos A into cos A. So in the numerator we have 2 cos A, isn't it? So this cos A and this cos A can be cancelled. So 2 upon cos A remains. 2 upon cos A. Okay. Cos square A means cos A into cos A. 1 cos A and 1 cos A from the numerator and the denominator gets cancelled. So we have, so we must put equal to or sign here, isn't it? Or 2 upon, this is 2 upon cos A, isn't it? Cos A equals to 4. Let me continue here. So this 2 goes to the denominator by cross multiplication, isn't it? 2. So this cos A, if we take to the numerator, this becomes sec A. Cos A, when we take to the numerator, becomes sec A, because cos A and sec A are reciprocal of each other. Cos A equals to 1 upon sec A and sec A equals to 1 upon cos A. Okay. Cos A and sec A are reciprocal of each other. So if we take this cos A to the numerator, it becomes sec A equals to, we have 4 here. Now this 2 goes to the denominator because we have 1 here. 2 1s are 2. 2 goes to the denominator by cross multiplication in the right hand side. Okay. So 2 1s are 2, 2 2s are 4, or sec A equals to 2, isn't it? 2 means sec 60 degree. The value of sec 60 degree is 2. Sec 60 degree means 2. Or sec, we cannot cancel sec. Okay, we just leave sec from both the sides. Therefore A equals to 60 degree. I hope you got this. So you can do by another method also. If you do not know the value of sec, okay, then you can use cos also. So we have 2 upon, this is the answer. Okay, we have 2 upon cos A equals to 4, isn't it? 2 upon cos A, 2 upon cos A equals to 4. We can do this by this method also. 2 upon cos A equals to 4. So this 2 1s are 2, 2 2s are 4. We can cancel this straight away. So 1 by cos A equals to 2. 1 by cos A equals to 2, isn't it? 2 means 2 by 1. 2 by 1. So we apply invertendo, means in the left hand side we take the number from the denominator to the numerator and numerator to the denominator. Similar thing we do in the right hand side as well. We take the number from the denominator to the numerator and numerator to the denominator. Okay, so this becomes cos A by 1. Cos A by 1 means cos A equals to, this 1 goes to the numerator, 2 comes down to the denominator. Here this 1 comes down to the denominator. So cos A by 1 means cos A. We don't write 1 because every number has 1 in the denominator, isn't it? So cos A is equal to 1 upon 2. So this means cos A equals to 1 upon 2 means cos 60 degree. The value of cos 60 is 1 upon 2. Therefore we leave cos from both the sides. A equals to 60 degree. You don't need to do by both the methods. Okay. If you do not know this, I showed you, just if you do not know the value of sec 60 degree, then you can use cos. Okay. If you do not know the value of any trigonometrical identity angle, okay, then you can just convert that into sine and cos form. Okay, I hope you got this. Now let's do the next question, question number 2 of 13. Now let us do question number 2 of 13. angle A lies between 0 degree and 90 degree. Angle A is greater than 0 degree, okay? Angle A is not equal to 0 degree, but the value of angle A should be greater than 0 degree and should be less than 90 degree. We must keep this in mind. So we are provided with this equation. From this equation we are asked to find the value of angle A, and angle A lies between 0 and 90, okay? So let's do this. Or let us take the LCM of the denominators. Sec A minus 1, sec A plus 1. We just multiply these two numbers to take the LCM, isn't it? So sec A minus 1 into sec A plus 1. This means A minus B into A plus B. A minus B into A plus B. This means A square minus B square, isn't it? A square minus B square. So 1 square is 1. We don't need to write this square, isn't it? So A square minus B square. Now when we multiply this with this, we get this, isn't it? Sec A minus 1 into sec A plus 1 gives us this. So sec A plus 1 into sin A. Sin A into sec A. Sin A into sec A plus sin A into 1 is sin A plus comes here sin A into sec A, sin A into sec A plus into minus sin A into 1, sin A equals to 2. Now we have minus sin A and plus sin A, same number, opposite sign. This is plus and this is minus, so we can cancel this two. So sin A sec A plus sin A sec A means 2 sin A into sec A, isn't it? Sin A sec A, sin A sec A, both are plus, so we need to add these two numbers, 2 sin A sec A. In the denominator we have sec square A minus 1. Sec square A minus 1 means tan square A, isn't it? Since we know that sec square theta minus tan square theta equals to 1, so we bring this 1 to the left hand side and take this minus tan square theta to the right hand side, okay? Sec square theta, let's bring this 1, minus 1 equals to minus tan square theta goes to the right hand side plus tan square theta. So sec square theta minus 1 equals to tan square theta. This means sec square A minus 1 means tan square A, okay? Or equals to 2, isn't it? We have 2. So this 2 and this 2 can be cancelled because this 2 goes to the denominator. 2 and 2 can be cancelled. So this is sin A by sec A, sin A into sec A. Sin A into sec A means sin A by cos A, isn't it? Sec A means cos A, 1 by cos A, because sec theta equals to 1 by cos theta. Sec theta and cos theta are reciprocal of each other, so sec A can be written as 1 by cos A. This sin A is this sin A. Sec A means 1 by cos A, so cos A goes to the denominator, isn't it? So this is tan square A. Tan square A equals to 1. Now let me continue here. Sin A by cos A means tan A. So tan A. Sin theta by cos theta is tan theta, okay? Sin A by cos A is tan A whole upon tan square A. Tan square A equals to 1. This one. Sin A by cos A is tan A, and this tan square A comes here, equals to 1. Okay? Or here we have tan A, here we have tan A into tan A. 2 tan A, isn't it? So this 2 and this tan A, this square and tan A can be cancelled. This means tan A upon tan square A means tan A into tan A. So this tan A and this tan A can be cancelled, so 1 upon tan A, isn't it? 1 upon tan A. This means 1 upon tan A equals to 1. 1 upon 1, we have 1 in the denominator, so we can bring this tan A to the numerator, 1 to the denominator. This is invertendo, isn't it? So tan a upon 1 equals to this 1 goes to the numerator, 1 comes down to the denominator, 1 upon 1 means 1. So we don't have to write 1 in the denominator because every number has 1 in the denominator always, isn't it? So tan a equals to 1. This means, or tan a equals to tan 45 degree, because the value of tan 45 degree is 1. So we cannot cancel tan because these are identities. So we leave the tan from both sides. Therefore, angle A equals to 45 degree. The value of angle A is 45 degree. Okay. So angle A lies between 0 and 90. That is 45 degree. I hope you got this. Now let's do question number 14. So let's do question number 14. So we are asked to prove this equation. In the left hand side we have cosec a minus sin a into sec a minus cos a into sec square a. So this is the left hand side. Using this left hand side we are asked to prove this equals to tan a in the right hand side. Okay, so let's do this. So this question has been asked in the icse examination 2017. Okay, this is one of the important question. So let's do this. LHS, first we copy left hand side. Okay, cosec a minus sin a into sec a minus cos a into sec square a. So this is left hand side. Cosec a means we convert this into sin a. Okay, 1 upon sin a, because cosec and sin are reciprocal of each other. So cosec a means 1 upon sin a, minus this is sin a. Sec a, we convert this into cos a, 1 upon cos a. Cos and sec are reciprocal of each other. So sec a means 1 upon cos a, minus this cos a comes here. So this is sec square a, isn't it? Sec square a means 1 upon cos square a. So let's take the LCM. Sin a and 1, the LCM will be sin a. So sin a into 1 gives us this sin a. So 1 into 1, 1, minus 1 into sin a gives us sin a. Sin a into sin a, sin square a, into, let's take the LCM. Cos a and 1, the LCM will be cos a. Cos a into 1 gives us cos a. So 1 into 1, 1, minus 1 into cos a gives us this cos a. So cos a into cos a, cos square a, into 1 by cos square a. So 1 minus sin square a means cos square a, isn't it? Sin square theta plus cos square theta equals to 1. This means cos square theta can be written in the form 1 minus sin square theta. We take plus sin square theta to the right hand side, minus sin square theta. Similarly, if we want to find sin square theta equals to 1 is already in the right hand side. We take plus cos square theta minus cos square theta. Okay, both are correct. Either you can use this or this. Cos square theta means 1 minus sin square theta, and sin square theta means 1 minus cos square theta. So 1 minus sin square a is cos square a, upon this sin a comes here, into 1 minus cos square a means sin square a. 1 minus sin square a means cos square a. 1 minus cos square a means sin square a. Okay, 1 minus cos square a means sin square a. This is cos a in the denominator, cos a. So into 1 by cos square a. Now we have cos square a in the numerator and cos square a in the denominator. So we cancel this. So we have sin square a in the numerator and sin a in the denominator. So let's cancel sin a, sin a. So still we have sin a in the numerator, 1 sin a, that is sin a upon cos a, isn't it? So sin a upon cos a means tan a. Therefore sin a upon cos a means tan a, and tan a is what we have in the right hand side, isn't it? So this is equal to RHS. Hence proved. I hope you got this. Now let's do question number 15. Okay, now let us do question number 15. Prove the identity we have this in the left hand side, sin theta plus cos theta into tan theta plus cot theta. Okay, so we are asked to prove this equals to sec theta plus cosec theta in the right hand side. So this question has been asked in the year 2014. Okay, and the previous question, question number 14, was asked in the year 2011. Okay, not 2017 but 2011. I told you 2017 earlier, isn't it? Actually it was asked in the year 2011. So this is the question. We are asked to prove this left hand side equals to right hand side. So let's do this. LHS equals to, we have sin theta plus cos theta into tan theta plus cot theta. So we are going to use this and prove this equals to sec theta plus cosec theta. Okay, so let's copy this as it is, sin theta plus cos theta. Now we convert this 2 into sin cos form. Okay, tan theta means sin theta by cos theta, tan theta means sin theta by cos theta, plus cot theta means cos theta by sin theta, cos theta by sin theta. Now we copy this as it is, sin theta plus cos theta. We have cos theta and sin theta in the denominator, so we take the LCM, cos theta into sin theta, that is cos theta into sin theta. We multiply these two numbers to take the LCM. Okay, cos theta into sin theta, cos theta sin theta. So cos theta when multiplied with sin theta gives us this, that means sin theta into sin theta, isn't it? Sin theta into sin theta, sin square theta, plus sin theta into cos theta gives us this, so cos theta into cos theta, cos square theta. Now sin square theta plus cos square theta means 1, isn't it? So sin theta plus cos theta into 1 is, now we have a into 1 equals to a, 2 into 1 equals to 2, 100 into 1 equals to 100. When we multiply any number with 1, we get the same number, isn't it? So this means sin square theta plus cos square theta is 1. This is the formula. We know this formula, isn't it? Sin square theta plus cos square theta equals to 1. This is the formula. So sin square theta plus cos square theta is 1. So this means this is 1. So sin theta plus cos theta into 1 is sin theta plus cos theta. Sin theta plus cos theta whole upon, we have cos theta into sin theta, cos theta into sin theta. Okay, now we write this separately in the denominator of sin theta and cos theta. Okay, sin theta upon cos theta sin theta, cos theta sin theta, plus cos theta upon cos theta sin theta. I am writing this separately in the denominator of sin theta and cos theta. Okay, when I take the LCM, this becomes again this, isn't it? So sin theta and sin theta can be cancelled here, cos theta and cos theta can be cancelled here. So 1 upon cos theta, isn't it? So here we have 1 upon cos theta. So cos theta, if we take this cos theta to the numerator, it becomes sec theta, because cos theta and sec theta are reciprocal of each other. So if I take cos theta to the numerator, it becomes sec theta, plus, so here we have 1 upon sin theta. Sin theta and cosec theta are reciprocal of each other. So if I take the sin theta to the numerator, it becomes cosec theta. So sec theta plus cosec theta is what we have in the right hand side, equals to RHS. Hence proved. Okay, so this is the solution for question number 15. Now let's do question number 16. Okay, now let us do question number 16, the last question from this exercise. Okay, evaluate. Evaluate means we are asked to find the value of this expression. Okay, Sine square 28 degree plus sine square 62 degree plus tan square 38 degree minus cot square 52 degree plus 1 upon 4 sec square 30 degree. So this is the expression given to us. We are asked to find the value of this expression, and this question has been asked in the year 2017 in the icse examination. Okay, so let's do this. It's one of the important question, easy but important. Okay, so sine square 28 degree we copy as it is, sine square 28 degree plus, now I change this, okay, 62 degree. Sine square, instead of 62 I can write 90 minus 28, because subtracting 28 from 90 gives us 62, isn't it? 10 minus 8 is 2, this becomes 8, 8 minus 2 is 6, means 62 means 90 minus 28. 90 minus 28 gives us 62. This sine square is this sine square. Okay, so I copy this as it is, tan square 38 degree minus, now I will change this 52, cot square 52 means 90 minus 38. 10 minus 8 is 10 minus 8 is 2, and this becomes 8. 8 minus 3 is 5. 90 minus 38 gives us 52. Okay, 90 minus 38 gives us 52. So plus 1 upon 4 sec 30 degree. Sec 30 degree means root 2 by root 3. So we should know the value of the table. Okay, sec 30 degree. Sec 30 means 2 by root 3. So this is squared. Sec squared means we must square this, isn't it? Sec square means we must square the value of sec 30. Sec 30 means 2 upon root 3. If you do not know the value of sec 30, just think of cos 30. Cos 30, okay. Cos 30 degree means root 3 by 2, isn't it? If you do not know the value of cos 30, think of sin 60. Sin 60 equals to root 3 by 2. If sin 60 is root 3 by 2, then cos 30 is root 3 by 2. If you know the value of cos 30 degree now, you can just take the number from denominator to numerator and numerator to denominator. Cos theta and sec theta are reciprocal of each other. Cos 30 is root 3 by 2, means sec 30 is 2 by root 3. Okay, if cos 30 is root 3 by 2, then sec 30 is 2 by root 3. Cos 30 and sec 30 are reciprocal of each other. So sec 30 degree means 2 by root 3, sec square means we put the square here. Now we have sine square 28 degree, sine square 28 degree plus sine 90 minus theta, sine 90 minus theta. Sine 90 minus theta is cos theta, okay, and tan 90 minus theta is cot theta, and cot 90 minus theta is tan theta. Okay, these are the formula which we have already done in our previous exercises. You can check out the video in the playlist. Okay, so sine 90 minus theta is cos theta, so cos theta is 28 degree, isn't it? So this square comes here, plus tan square 38, we copy as it is, tan square 38, this minus sign comes here, cot 90 minus theta, theta is 38 degree, okay, so cot 90 minus theta is tan theta, cot 90 minus theta is tan theta, tan 38, theta is 38, so square means we must put a square here, plus we have 1 upon 4 into 2 square means 4 upon root 3 square means 3, isn't it? So 2 upon root 3 squared means we must apply this square to numerator and denominator, both the numbers, because both the numbers are within the bracket, isn't it? So 2 square means 2 2s are 4, root 3 square means root 3 into root 3, isn't it? So 4 upon root 3 into root 3 is root 3 into 3, isn't it? So 4 upon 3 3 we make the pair and take out from the root, okay, 4 upon 3. So this 2 squared is 4, root 3 squared is 3. Now we cancel this 4 and 4 from the numerator and the denominator. So sine square 28 plus cos square 28, same thing, angle is same, isn't it? 28, 28. If the angles are same, then sine square theta plus cos square theta is 1. We must keep in mind that the angle must be equal, okay? Sine square theta plus cos square theta is 1. So plus this tan square 38 is plus, tan square 38 is minus, so we can cancel this two, this becomes 0. Now we have plus, this plus, because these two are 0, so plus, this plus comes here, 1 upon 3, 1 upon 3, isn't it? So 1 plus 1 upon 3 means 1 whole 1 upon 3, okay? So this is the answer. You can solve this in this way. We take the LCM, 3 and 1, there is 1 in the denominator, 3 and 1 LCM is 3. So 1 into 3 is 3, so 3 ones are 3, plus 3 into 1 is this 3, so 1 into 1 is 1, 3 plus 1 is 4, 4 upon 3. So this is an improper fraction because denominator is smaller than the numerator. We convert this into mixed fraction. 3 ones are 3, 4 minus 3 is 1, so 1 whole, this remainder goes to the numerator, divisor comes down to the denominator, 1 whole 1 upon 3. So no need to do all this process because this, if this is plus, we just bring this here, 1 plus 1 upon 3 means 1 whole 1 by 3, okay? I hope you got this. This is just the time consuming, isn't it? So this is the last question from this exercise. I hope you understood the concept of trigonometrical identities, okay? So in our next video, we will start from height and distance. Till then, stay blessed, stay connected and study well, okay? Practice well. Thank you.